Container breakout vulnerabilities are not new. It has happened before, it has happened now, and it will happen in the future. Recently, there was a very interesting blog article by Wiz researchers when they uncovered the NVIDIAScape CVE 2025-23266. This is a very critical vulnerability of container breakout that impacts the users of the NVIDIA Container Toolkit. Now, the NVIDIA was great in patching it in their version 1.17.8, but let's try to understand what has happened, how to reproduce it, how to have a preventive measure for such kind of vulnerabilities that will come in the future, and what is the industry saying. So when it comes to the AI infrastructure, obviously we are talking about the GPU nodes. We are talking about Kubernetes clusters with GPU nodes, and the Kubernetes clusters are running the containers. With this vulnerability, there is a new talk in the town that is going within the industry that people are saying go back to VMs, like have VMs on top of the AI infrastructure rather than running containers directly on the GPU nodes. While the VMs have the strong kernel isolation, they have significant drawbacks like the overhead, performance, complexity. And then why do we want to move backwards? Like we are moving towards a containerized architecture. We have microservices. We want to leverage the powerful capabilities of Kubernetes. Then why to go back? We should use the container ecosystem. Past KubeCon in April 2025, we introduced something which is called vNode. So vNode is a Kubernetes container-based isolation technology that combines the approach such as the user namespaces, seccomp filters, file system emulation, and a bit more stuff going around to create a secure, isolated sandbox for running the user-defined containers. We assume that the user-defined containers are vulnerable by default, so we don't apply any security measures against the user-defined containers. We say that user-defined containers can be vulnerable, can be compromised, can be container breakout. And even if the container breaks out that is running on a virtual node, it will only get access to that isolated virtual node environment. It will never get the access to the host GPU. That's where vNode is helpful. Let's try to break down first what NVIDIAScape was, how an attacker can actually create an attack, and then how it looks like when you have a solution like vNode in place. So in OCI, the Open Container Initiative, there is a standard for container runtimes, and there is a hook system. And NVIDIA Container Toolkit heavily uses this hook system. In that hook, there is a specific hook called create container. This hook is executed as a privileged process on the host before the container's root operation and after the mount namespace is created. Unlike the pre-start hooks, container hooks inherit the environment variables. This is very important that it inherit the environment variables. So what happens is there is the NVIDIA Container Toolkit, which performs the GPU access. It runs as a privileged host during the create container hook. Unlike the other hooks, it inherits the environment variables directly from the container images. This means that attackers can leverage something which is called LD preload. So this is the Linux environment variable, LD preload. And by setting this to a path within the container, the attacker forced the privileged NVIDIA CTK process to load and execute an arbitrary malicious shared library. So I already have created a EKS cluster using EKS create command. And I can show you the config file which is there. So EKS. That's the config file. So cluster config, vcluster GPU. You define some tags, give CIDR ranges. And in this, you define the instance type. So I just need one instance. So it's a single node pool in the EKS Kubernetes cluster. That is G4D and extra large. So I have the Kubernetes cluster up and running. The next thing is we'll try to get the kubeconfig file. So AWS EKS update kubeconfig, region US East 2, vcluster GPU, and the kubeconfig file. So this is where the kubeconfig file is. I'll also export kubeconfig, kubectl get nodes. So there you have a single GPU node Kubernetes cluster. The next step is to install the vulnerable GPU operator. So which is what we are trying to do now. Helm install GPU NVIDIA operator version v2530 in the namespace GPU operator, create namespace. This will install the NVIDIA Container Toolkit version less than v117.7 because the NVIDIA fixed that in the Container Toolkit version v1.17.8. So the GPU operator is now deployed. It would have start creating some pods. kubectl get pods -a. And we can see the pods have started to come up and some are in the container creating state. The next thing is creating a C file. So the file that I have, it is pretty simple. It demonstrates the unauthorized code execution inside the container. It has standard libraries that is included and a special attribute constructor before the init function ensure that the function is executed automatically when the shared object or the binary is loaded. Inside the init, the code tries to create or open a file named /owned in the root directory of the file system on the host on the GPU node. If it's able to do that and it's able to write exploited to this particular file, that means the exploit is successful. And this is the kind of example for the container breakout in this particular scenario. Let's compile this. So I'm using Docker run platform Linux and then compiling this. So it will take some time to compile this and create a poc.so file. The next step is to build the image, and we can see the Docker file that is being used in that. Again, as mentioned, the env is ld preload and /proc self cwd/poc.so. So let's build the container image. You can also use ttl.sh as an anonymous registry, or you can use your own registry. The image is built in push, and I already have created an exploit file. So malicious pod.yaml. You can see API version v1 pod, restart policy never. In this is important. NVIDIA as the runtime class. So kubectl get runtime class. You will see NVIDIA over here. We need to use that. Image pull policy always, and we just need to change the image to what we have. So malicious pod.yaml, and we'll use the one that we have just tagged over here and post. And then in the resources and the limits, nvidia.com/GPU. So let's see kubectl get pods -a. Okay, we still have one of the operator validator in init phase. So let's wait until all the pods are up and running. All right, so all the pods are up and running. Now we'll deploy the malicious pod, kubectl apply -f malicious pod, kubectl get pods. It's pending and it's in running state. Now there's another host checker pod. So there are two ways. Like if you already know Kubernetes, you can have a privileged pod running on the host. So what we are doing here is we are running a pod on the host with privileged true. So, and we are mounting the root directory of the GPU node into the /host of the pod. So you can also directly SSH onto the node and check. But we'll use the Kubernetes-native way. So kubectl apply -f host checker.yaml. And now we can check kubectl exec host checker, and we can see there is a host file that got created. And if we cat that, boom, exploited. This particular file is actually created on the host. So this is what happened. NVIDIA GPU operator, the create container hook run from the environment variable and exploits the host. The file is created and exploited is written over there. Now, let's try to replicate and try to run the same thing, but this time using vNode. So before that, we need to install vNode. And for that, we need to install the vNode runtime. and we need to set two variables, which is the platform host and the platform key. How you can get that? You can use your own platform, or you can use vcluster.cloud. I already have vcluster.cloud, and I'll create an access key for this particular scenario, and we'll name it we'll use it for all projects, and we'll name it vNode demo. Save. So this is the access key. No worries, I'll delete it after the demo. Will be my platform host. So we say enter, and it will install the vNode runtime. The vNode runtime is installed. If I now do kubectl get runtime class, there will be a new runtime class specific to vNode getting added over here. Now, before trying out the same experiment on a virtual node, we need to remove the file that was created. So I have already logged in, and if I do a ls/owned, I can see that file cat/owned, and I can do a rm-rf of /owned. So now the file is removed. Now let's deploy another pod, which is malicious pod vNode, because now we have the vNode runtime. So instead of the NVIDIA runtime class, we'll use the vNode runtime class. Rest, everything remains the same. So kubectl apply -f malicious pod vNode. Kubectl get pods. It is pending, and it is running. So this pod is running. Now we again need to see whether stuff was created on the host cluster. That's the exploit, right? So we come back and we do a ls of owned. There is no such file or directory. There is no such file or directory on the host cluster. Let's try to see what it did, because the exploit happened, but where it happened? It happened on the virtual node. How we can check that? I have vNode privileged. I have another host checker pod, but this time I'm running a privileged pod inside the virtual node, which is why I have specified the runtime class as vNode, and I have mounted in the same way. So kubectl apply -f vNode privileged pod, kubectl get pods, the pod is running, the host checker pod is running. Let's exec into that. And there you go. There you go. You have the file /own. You have this particular file which is there on the virtual node, but not on the actual GPU node. I can again show you, it's not on the actual GPU node, but on the virtual node. So to conclude, NVIDIAScape is just one vulnerability. These container breakouts will keep coming on. The very simple answer to it is like, use VMs for everything, but that is something that going backward and not towards the modern architectures, the high performance environments, and using the ecosystem of Kubernetes. So for this particular thing, if you are already using some of the systems, you can patch to the version 1.17.8, which contains the fix, or you can simply start using a vNode, which provides a lightweight virtual node layer that automatically creates a runtime class in your Kubernetes cluster. And it wraps the Kubernetes workloads that might have vulnerabilities in secure sandboxes. Even if the container breaks out, it is on the virtual node and never reaches to the actual host. Again, if you are affected by this vulnerability, or if you want to prevent against the similar attacks, happy to talk about virtual node. Do leave us in the comment section, or ping us on Slack. Happy to chat about vNode and container breakouts. Thank you so much for watching. See you in the next one.